focusing on other capabilities around redundancy, specifically on how we can configure historical redundancy inside of InTouch. I think in this episode, we're going to break down what redundancy really means around an HMI application, such as InTouch, and really contrast and compare between systems like System Platform. And give you the reasons why you should care about it and how to implement it with smart and simple, failover configurations. As you know, we have the same sort of group of hosts today, Maryalice and Brian, who joined us in the last session. And really, before we start into the main discussion points, I kind of want to get your thoughts around this sort of topic in general.
Yeah, so I think before we dive too deep into the topic, I think it's important that we first define what redundancy actually means. So, this is a very simple definition, but essentially, redundancy means having two of the exact same thing, or really a backup in case of a critical failure. And so, if we think about this in regards to the industry, you could have one HMI workstation fail and then use a backup workstation to still be able to control your system. Or, for a SCADA system, if the primary server fails, the standby server will automatically take over without losing any of your process data.
Yeah, I think that's exactly right. There's also a lot of different things that come to people's mind when they think about redundancy too. There's like the application redundancy, there's alarm redundancy, there's scripting redundancy, there's historical redundancy. Today I think we just really want to focus on that historical redundancy. So what happens to the data being stored when InTouch goes away?
Yeah, and Brian, you mentioned there's a lot of requirements for redundancy, isn't it? I mean, how can we simplify this for our audience today?
Yeah, so maybe I can simplify this a little bit here. So if we think about a traditional HMI like InTouch, typically that means customers have their InTouch HMI running on one workstation. However, there's also the requirement for a lot of our customers to have IO as well as historical data redundancy as part of their systems to ensure that information isn't going to be lost in case of a failure. So maybe what I can do here is show just a quick view of how we can set up IO redundancy within InTouch. So I'm sharing my screen here, and what we have within InTouch are our access names. And these access names is where we can actually set up InTouch to communicate with our communication drivers like OPC UA, MQTT, any protocols. And really all that you need to set up an access name are three things. You need the network name of where the driver is. You need the application name, so this refers to the service that we're calling up. And then you also need the topic name, which is the scan group. So this typically designates the tags that we're pulling in and how often we're pulling that information. And so what you can do in order to set up IO redundancy is check this box to enable a secondary source. And when you select to enable this secondary source, you can also specify a expression or a condition that will trigger the failover to that secondary source. So this is kind of that IO redundancy piece and how we can set that up. For the historical data redundancy piece that we're going to be primarily focusing on today, we're actually able to provide you guys with some sample code. We'll talk about that a little bit more shortly. But this will allow you to set up your InTouch applications for historical redundancy, which will allow you to preserve your data in case of a failure for one of your InTouch nodes.
Well, that's great. So built-in IO redundancy as well. So you show that pretty simple, couple check boxes there, and InTouch has that built in. But a lot of times when people think about that redundancy, there's all kinds of other things that come into play with that high availability and disaster recovery and load balancing and all those things like that. So like what's really important for somebody in those applications? At Aviva we have solutions for all those applications. When you look at System Platform, it has a checkbox for complete redundancy built in that handles everything. But here we're just kind of talking about InTouch, which can do quite a bit for those people that are using InTouch. So another thing that's important to mention too is some stuff has changed with InTouch. So years ago, InTouch used to store its data to historian, and the historian would kind of go out and reach for that data. It's a little bit different now. So now it's just a matter of InTouch pushing that data from window viewer off to the historian. So configuration in window maker, check a box, and that data gets pushed to historian. It uses some technology called HCAL, a historical client access layer. Don't need to get into that details. It's just a checkbox, so it's pretty simple. So you go in InTouch, you enable that, and there it goes, right?
Yeah, and when you do set up InTouch to send data to the Aviva historian, it can also continue to log that data to the LGH file as well. So this is kind of a type of insurance in case maybe there is some type of loss of connection to the Aviva historian.
Yeah, and okay, well, I really appreciate the overview, but one of the burning questions I have in my mind, based upon some of the conversations I've had or just heard things through the forums, is setting up redundancy within InTouch is fairly complex, especially around the historical data piece. Is this sort of a true statement? I mean,
No, I mean, I want to jump in there. I don't think that's true. I mean, it's a fairly simple process. The actual process to set up the historical data redundancy in InTouch, first of all, it's not only possible, but it's pretty straightforward and easy for someone to do. It does require some scripting, but it's not a whole lot, you know. So overall, I think people will be really surprised how simple it is in order to do that.
Yeah, and just to remind everyone as well, we have a blog post on this topic that Omar is going to be linking to right now, where you can go through the full details of actually how to set up historical data redundancy. And just for the sake of time today, we're not going to go into the detailed process of setting up historical data redundancy in InTouch, but you can go through this at your own pace.
so just another big question I have is, in and around this sort of conversation that we're having, is why would someone care about using historical data redundancy within InTouch? I mean, we have a bunch of other applications out there. Why InTouch?
Well, so, like anything in operations, downtime is costly, right? Whether it's due to whatever causes it, a power loss, maintenance on a PC, an operating system crash. If your HMI goes down and you're not logging alarms, you're not logging history, you're flying blind in that process. You don't really know what's going on. And then after the fact, if you need to go take a look at what happened, you don't have that. So having redundancy gives you that peace of mind. If one node fails, the other one can pick up right where it left off. And again, just the fact that InTouch can do it as well, and there's those many InTouch applications out there that can do that today, I think is a really powerful feature.
Yeah, and just to add a little bit to what Brian's saying, when we set up the redundancy in InTouch for the historical data redundancy, we can ensure that alarms as well as historical data are staying intact. So that way that data isn't being lost at all when there's, that minimal downtime during the automatic failover.
All right. Well, and I think I get it. In my mind, maybe like an example to give the audience is like a water wastewater customer who has to deal with regulatory requirements on capturing data is really important to them, and any losses that they have in their data could mean issues for that sort of operation. So maybe if we can we walk through the audience on just how we could do a basic setup of what we talked about for redundancy here?
Yeah, so maybe I can show you some of that here. What I'll do is I'll pull up this architecture here that maybe kind of helps explain how this actually works. So from a high level, we have two InTouch nodes that are both running the same application. And really, we want only one of them to be actively logging historical data and alarms at a time. And so the way this is going to work is node one will start as active. So it's logging the alarms, it's logging the data. And then node two will start as passive. So it's running, but the logging and the alarm is disabled on this node. And what will happen is when there's a failure on node one, node two will detect that its partner node is inactive. And so on node two, it will start to log the data and log the alarms. And then when node one comes back online, it will then see that node two is active. And so node one will stay passive until there's a failure on node two.
Yeah, so I mean that's pretty simple, right? So it's the same application running on both nodes. Really, the only difference is that access name that you have between the two nodes that keeps track of if the other node is there, kind of doing its job. So even if you have to modify the application or make changes, you simply make the changes, go back, update the access name, and everything is good to go. It's the only thing that needs to be updated. So that seems pretty simple.
Yeah, and so, Brian mentioned earlier that we have a, you know, little script that we do need to do this. So, um, I'll pull that up here. And what you can see is, again, it's a pretty simple script that what it's doing is it's looking at the status of the partner node. And when it detects that the partner node is offline, it will then locally enable the logging and alarms.
All right. I think we talked a lot about the sub and just the detailed mechanism around it, but what I really want to show this audience that's on the call today is really I want to see this live in action, prove that it actually works, not just like pictures and slides there. So let's see it. Let's see it go.
Yeah, let's take a look at this. So right now I have node 1 currently running as well as node 2, which I'll pull up here. And what we're able to see is that on node 1, it's currently actively logging the data and the alarms. And one thing to just briefly point out, you do need IPv6 disabled for this to work. And so what you can also see is that the status of my partner node is off for the logging of the data as well as the alarms. And so what I'm going to do to simulate a failover is I'm going to close window viewer on my node 1 here. And what you're going to see happen is node 2 will detect that the partner node is offline, and you can see that it's already automatically started that failover of logging the data and logging the alarms.
So that's interesting. So what happens in that failover is the two stop communicating, but one node simply knows that the other node's status has gone bad, and it picks up and starts taking care of, logging those alarms, right? So when it comes back, the status would update, and you'd know exactly what's going on, which is pretty clear with what you've shown there, I think.
Yeah, and just like I mentioned earlier, if I were to pull node 1 back up and say it's online, node 1 will remain as passive, so node 2 would continue to be logging the data and the alarms, and then until there was a failure, then node 1 would pick that up and it would fail back to node 1.
All right, so the status just updates as soon as the two nodes start communicating with each other, and it can determine what to do on that changeover.
Mm-hmm.
So maybe just a question on my end of things. What happens in between sort of the seconds when you fail over the systems, right? I mean, is any of the data lost? How does it visually look like in sort of that trend or visualization node that you set up here?
Yeah, that's a good question. So I actually have this trend in my historian that I'm going to pull over here that we can take a look at. And what you're able to see on this historical trend is I do have a little gap here where, that's where that automatic failover occurred from node 1 to node 2. So really a very minimal amount of data was lost during that couple of seconds of automatic failover.
Sorry, and I got maybe another burning question in my mind. And when you talk about this, I see the failover, see how things look at from a data perspective. But I mean, to me, when I take a look at the architecture, I got node 1, node 2 for InTouch, and they're automatically, you know, are they automatically collecting information? Is there any duplicate data? How's that all handled, I guess?
Well, so I just jump in here for a second. I mean, the historian is going to handle that because it is, again, InTouch is pushing into the historian, so that data is being pushed into the historian. So during your retrieval, you won't have any duplicate data. You'll just have all of the process data that was stored. So it's pretty simple.
Okay. And this is really awesome. Really cool to see sort of that smooth transition and just automatic handoff when the failover occurs within these InTouch applications. Maybe just a quick question for both of you: is there any best practices for people for trying this out in their own environments or own systems? I mean, what kind of tidbits can we sort of release out to everybody?
I mean, I think it's pretty straightforward for anybody who has those two InTouch nodes. You simply point it to the same historian and you enable and disable the logging based on which one of those is active. So I think it's pretty straightforward. The script takes care of enabling and disabling, and there you go.
Awesome. Awesome. And sorry, I'm just looking at the time right now. It looks like we've gone a little bit over. And this means, unfortunately, we reached the end of our 15-minute episode, and in theory, the end of this program. So, if you'd like to get your ideas onto the show, put your ideas into our Aviva Heroes HQ forum, or reach out to us on our LinkedIn or Twitter feeds at Aviva. Really appreciate your time today on the call, and let us know if you have any technical needs. But thank you, and looking forward to the next session there.
Cool. Thanks, everybody.
Yep, thanks.